So we're going to be talking through two different strategies here for plastic molding. Starting out with a little bit of the challenges of the injection molding process, or what I'm going to refer to in this webinar as the DC2 process, where we have two decoupled sections from one another. We have the constant flow rate section and the constant pressure section in a traditional injection molding process. The issue primarily with that process is that we need to increase our pressure gradually in order to get up to or in order to maintain that constant flow rate during the filling stage. This can cause a lot of internal pressure for the plastic, which can be difficult to control from a uniformity of volumetric shrinkage. And then it can also lead to a really high amount of clamp tonnage required, especially when we start talking about higher cavitations. There's also a really abrupt and sensitive transition between the filling and packing stage when we are switching over from that velocity control stage to the pressure control stage, or the VP switch. That transition can be quite abrupt. And then there's a lot of independent variables that require a lot of manual tweaking on the process floor. So the two sensor feedback strategies that I'm going to talk about in this webinar are the iMFLUX process, which uses a low constant pressure filling, and then it applies a sensor feedback to pack the material as it flows. And then the DC3 process, as it's traditionally called, or decoupled 3, which just employs a late kind of like a secondary switchover during the kind of in the middle of the filling process to reduce the amount of pressure at the end of fill. Drops our pressure requirement quite a bit, but it also helps us to decrease the internal pressure of the plastic, and it uses a sensor control for that sort of switchover technology as well. All right, I'm not going to go over only the application of iMFLUX, but also more on the how it interacts in Moldex 3D Studio. But first of all, let's talk about what is iMFLUX. So iMFLUX is a low constant pressure control method of molding. Now, using a constant pressure actually ends up being a really nice methodology for being able to fill out the part and have the properties of the plastic be a little bit more uniform, as we're able to kind of pack out the material as it flows through the geometry. The only issue with the constant pressure type of molding process is that the momentum of the material is going to slow down gradually, and it's possible that we get a short shot. It's actually very possible that we get a short shot using this constant pressure molding. We might know this if you've ever hit a pressure limit in the simulation or in reality. If you've ever hit the pressure limit of the machine, we get a short shot because it's pressure limited, right? That's kind of what we're doing here. We're kind of setting a constant pressure, and we're allowing the material to flow under that constant pressure rather than using a constant flow rate.